Okay, part 3 of the independent probability or conditional probability lesson. So first we're going to kind of develop a formula. So we're going to have a formula. So remember that the probability, this is the probability of B given A. Right? So I'm going to kind of show this as your friendly neighborhood Venn diagram. So this is A, this is B, and this part over here we're going to call A and B. So we want the probability of B given A. So B given A means that we're in this zone over here. So that's our A. So we know it's B given A, we are in A for sure. And the probability of being in B, so to be in B, we have to be in kind of in that pink area. So the probability of B given A is the probability of being in the pink given that you're in the pencil. All right, so that's going to be, don't write this down, the probability of pink over, that's kind of our NA, over the probability of being in the pencil. Or, to put it another way, it's going to be the probability of A and B over the probability of A. So the probability of B given A, is the probability of A and B over the probability of A. And we can rearrange that to get that formula I kind of just pull out of nowhere on the previous part, right? Where what we could do is we could bring that up there, and we could say the probability of A and B is the probability of A times the probability of B given A. So that's a formula. It's good to know it. If you don't know it, you might be able to figure it out. Let's do an example with it. So I think we're on example 4 or so. Something like that. Okay, example 4. So let's say there is a 40% probability that your friend will cough today. And let's say there's a 30% probability that your friend will cough and they are infected with COVID-19. So 40% probability that they're going to cough, and a 30% probability that they're going to cough and that they're going to be infected with COVID-19. So the question is, your friend coughs. What is the probability that she has COVID-19? So again, pause the video if you need to write it down. So we have two events. Event number 1 is coughs, and event B is going to be has COVID-19. So the probability of A, the probability of coughing, is 40%. Now this 30%, what is that the probability of? So it's tempting to say it's a probability of B given A or A given B or whatever. Let's go to the end. Your friend coughs. What's the probability that she has COVID-19? So what are we looking for? So what we're looking for is we want a probability that she has COVID-19 given that she coughs. So we're trying to find the probability that she has COVID-19 given that she coughed. That's what we're looking for. So this 30% over here was not that. What this 30% was, that's the probability of both of them. That's the probability of coughing and being infected, and that was 30%. So then what we're going to do, we're going to go back to this handy dandy formula over there, and we're going to say the probability of the probability of B given A, the probability of having COVID given that you cough, is the probability of both of them happening divided by the probability of just coughing, which in this case is 0.3. By the way, in case it's not obvious, I completely made these numbers up. They have no connection to reality whatsoever. I have no idea what actual rates of anything are. So 0.3 divided by 0.4, which would be 75%. So, assuming that this was true, which again I emphasize is probably not, assuming this was true, if somebody coughs, there's a 75% chance that they have the COVID-19. That's a probability of B given A. Okay, I'll do one last example. You have a deck of cards. You take 20 of them. And you burn them. Without looking. So you haven't looked at the cards that you burned. I'm getting a new pen. Alright, so you had your 52 cards. And 20 got burnt. And now you only have 32 cards left. So if you pick one card off the top, and the question is, what is the probability that the card is the Queen of Spades? Okay, so give the answer in the comments, and if enough people do it, I might give the answer to that eventually. So I want the answer and also a mathematical proof, right? So using kind of the concepts that we had over here, how do you prove what the probability is of getting the Queen of Spades now? And remember, we didn't look at the 20 cards that we burnt. So we just into the fire. So I'm not sure what I'm going to upload. I'm either going to upload something from the textbook, in which case it would be page 334, 1 to 5, 7, 9, 14, 16, or it's going to be the Democratic problem set. And maybe I'll upload both of them. A lot will depend on my technical expertise. If you have any questions, you can also ask it in a comment on this video, or and hopefully other students can answer it, or I'll see how I'm going to figure it out. Okay, so hopefully this works in some way. Good luck. This was a hard lesson. I recognize it's difficult. These are not ideal circumstances. We're all going to do the best that we can. Okay, good luck.